Before I just start this presentation, I'd just like to make a quick disclaimer. If there are any representatives from Amazon, Microsoft Azure, Rackspace, any of the other big cloud providers in the room, you may want to close your ears for the next half an hour or so. Alternatively, there is actually some good news in here for you as well, so please don't take this the wrong way. There weren't a lot of options for the particular business case that this presentation is actually built on. So, a little bit about me. This is my first time presenting at UKNOF, and I'd like to thank the Programme Committee for selecting this presentation. I started as a software engineer, working at a CRM company. That was fresh out of university. I moved to an internet provider in Southampton in 2014, went to work for an IT consultancy working primarily with the railways, and then I left there at Christmas and now run my own IT consultancy, Delta V Technologies. Now, basically what I specialise in is difficult problems, and there's plenty of them out there, particularly in the networking sector. I do a bit of everything from day to day, so from software engineering. Yesterday I was writing code to monitor batteries, and I've been managing quite a lot of networks as part of it as well. So when I talk about the cloud in this presentation, there are a lot of definitions out there that I've seen, and I'm just going to define what I mean for the purpose of this presentation only. I'm talking about the public cloud. I'm talking about your AWS's, your Microsoft Azure's, Rackspace, Bytemart Cloud, places where you can go and rent a server for an hourly fee or a monthly fee or similar, and basically it's their hardware, your virtual machine. No real ties or commitments, and essentially they do all the legwork of providing the networking and all the complexity for you. And the public cloud is great, and this is why I say for the people in the room from public cloud providers, this isn't all bad news for you. For small projects, it works great. For research and development purposes, it works great. Because you can literally just go and rent a server for 3 or 4 hours, try something out, go and do what you need to do, and make it all work. For big scale projects, it generally works quite well as well. And what I've found is that a lot of my clients actually use public cloud facilities and it works brilliantly for them. However, there's this awkward bit in the middle of when you want to do something complicated with it, when you've got bespoke network requirements, all that sort of stuff, and it can get a bit difficult. That's not to say that any of the big cloud providers are doing it wrong, but there are certain use cases it doesn't work for. And essentially, for my particular client, it all came down to cost. In their case, what they were doing worked out cheaper to not be in the public cloud. For everyone, that won't be the case. And there were a lot of costs involved to actually getting it set up. You've obviously got to buy the hardware, you've got to buy all the networking gear, you've got to go and pay RIPE for membership and also for the IP addresses. And it does actually add up to quite a lot of money, but it was still less than their, at the time, Amazon AWS bill. Now, my client, they're doing information screens, and they started out doing print media, and they now moved into digital because that's the way that everything's going. And they started developing things in Amazon Web Services, and EC2, and the various services there. It worked out really cheaply for them to start with, until they started onboarding clients. And then they started discovering that all of these clients want VPNs to encrypt all the traffic between their services and these information screens. Despite the fact that it's all public information already, they wanted it encrypted. As a result, you start getting into the realms of lots of VPNs very, very, very quickly. And we had this architecture where client machines were connected back to the servers over a VPN, Over the public internet was also possible, but most of the clients of my client didn't really want that. And it was calling out to a lot of third-party services for most of the data. Essentially, my client is a data broker in between people who provide all this journey information and the actual people using these screens. And it turned into a problem of scale. The back end for their service is not resource light, unfortunately. For those of you that know how things scale in Amazon, they were actually using C4.large instances, and it was getting very, very expensive. The other problem that they were having was that they were only in one availability zone in Amazon, and they needed to scale into 2. And in order to provide proper redundancy. But the issue we were having was that in the particular configuration they were in, you couldn't have multiple VPN services to Amazon in different availability zones that would all just work together and fail over nicely. Now, I am prepared to be corrected on any of this, but certainly this was our experience of it, and we spent quite a lot of time working with technical support to try and find solutions, and we basically went, there isn't one. The other problem that we have is a massive addressing headache. Because all of these are IPsec site-to-site VPNs that these clients are using, a lot of the clients are using /16s on their VPN tunnels. Now, I know that not everyone in the room will be able to do their IP address addition and calculation very quickly, but essentially this means that we could get to 256 clients and then run out of addresses, pretty much, given that the vast majority of the clients are using the 10./8 address space on the other end of the tunnels. It proved very, very, very difficult very quickly. The only easy way we could see of getting rid of this was to start looking at VRFs and things like that, which aren't readily supported inside public cloud offerings. We actually ended up, in the case of several clients where their IP address ranges overlapped, adding /32 routes for individual IP addresses just to make the whole thing work. So we have to look at future solutions to our addressing problem that we've got, and we could use NAT, but part of the problem is that, as many of you know, NAT isn't always the answer, and in this case I think would probably be one of the more evil solutions. And VRFs get complex to manage, but at least we'd be able to keep all the customers properly separated. Maybe there's something else, and I would obviously welcome any suggestions at the end from the floor on other solutions to our rather rapidly approaching addressing problem. So, having realised that the public cloud wasn't going to easily be able to deliver the service that we wanted to be able to deliver and handle the addressing requirements and the VPN requirements that we were going to need, we looked to see whether we could run it ourselves. There's a lot of management and administration headaches with running your own systems. And my client actually has no IT support engineers, and that's why they have me, and due to their insistence on redundancy, another IT consultancy as well, which seems a little bit crazy, but it's how it works. Public IP addresses and working failover on those is quite difficult. And we had to go to RIPE, we had to register my client as an LIR, and that took some time in itself to actually get the address space. However, in part, we were unable to easily do this because the client, to do this with a single data center provider, as my client wanted redundancy across the data centers as well. There was also a 5-figure setup cost involved, which to some of you probably you're thinking, that sounds remarkably cheap. Now, yes, it is, but then we worked out how much kit was actually required to do this, and it wasn't a huge amount, and I'll show you roughly what we did in a minute. But essentially, it was becoming unsustainable in the cloud, in the public cloud, and we had to look at this client running their own private cloud where they could actually make it work properly. So we essentially went for the 2 by 2 by 2 by 2 by everything by 2, essentially. And with apologies to Tom Hill and his team at Bytemark for making their life very, very difficult for a day or two while I went and fiddled around in a rack in Bytemark to try and get all this working reliably. In general, it's gone relatively smoothly with all of this, but we've had to put 2 firewalls in redundant pairs, 2 switches, 2 servers, and each server is capable of running the full stack of their applications. And we've done quite a lot of work on the networking side to keep the redundancy and make that all work reliably. That said, anyone who thinks that running BGP off Cisco ASAs is easy, it really isn't. I have to say thank you to Tom for helping me out with that one when I needed to. And essentially, we spec'd it up using those, and I apologise for the typo that I spotted about 2 minutes before lunch. That should read HP 2530 switches, not 3520, but otherwise all correct. Because this client of mine isn't actually doing a huge volume of traffic, we were able to put relatively low spec hardware in. The 5508X is very much overkill from a networking perspective for what this client requires, and we are by no means taxing those units anywhere near what they needed to. And the switches were obviously running spanning tree and also where necessary link aggregation to provide some redundancy across the network in each of the 2 data centers. And as I mentioned, both of the servers are capable of running the full stack of the client software. And a rough diagram of roughly how it looks. You've essentially got, I'm going to try and find it, so you've got 2 uplinks coming in, one into each of the firewalls, and then each of the firewalls crossed it up into each of the switches, and then likewise each of the switches crossed up into each of the servers. The idea being that you can pull out about 75% of the cabling and it all just continues to work. Given the prominent location of some of my clients' units, it was kind of important that we did that. It might look like a bit of a mess on the diagram, but it can tolerate an awful lot of stuff getting unplugged. So here's what I actually ended up, that's roughly what it looks like in one of the data centers, and we've actually color cabled all the coding as well, color cabled all the cabling as well, I should say, to make sure it all looks reasonably easy to find in the event of an issue. And I'm going to skip slightly quickly onwards and basically explain a little bit about the software we used to achieve the redundancy as well. What we've got on each of the servers is we've got KVM and QEMU as a hypervisor stack, which I know that the team at Mythic have been using reliably for decades, and basically my client didn't want to spend any money, so we had to go with an open source solution. We've picked Keep Alive D for the redundancy on IP addresses, and that, although it has some quirks in certain configurations, we haven't yet found any of them, and we've done some fairly extensive testing. We use HA proxy, which some of you may have come across, some of you may not have come across. Again, that is doing most of our load balancing within the network as well. We use Nginx for our web servers and Puppet for our management. Essentially, Keep Alive D allows us to have multiple servers with the same roles installed on them, and then we use Keep Alive D to cascade any failures across them, so that we can get to so that if one fails, the next one takes over in the chain, and so on and so forth. Within each site, what we've actually done at the moment is 2 load balancers with KeepAliveD managing a floating virtual IP, 2 database servers, again with KeepAliveD managing a floating virtual IP. This is interesting because it doesn't always work reliably with databases. I'm sure anybody in the room who's pulled an IP address out from underneath a database server before has gone, that did something interesting. But we've just about managed to iron out the creases with that. Similarly, for outbound internet access and the VPN servers, it is important to note that KeepAliveD with VPN servers, particularly IPsec, gets very interesting unless you've got dead peer detection turned on. Those clients of my client that have got dead peer detection turned on all their VPNs, the failover works almost seamlessly. For those clients who have not got dead peer detection turned on, and this appears to be mostly people with checkpoint firewalls, so if there are any checkpoint people in the room, I would love to speak to you in the next coffee break, because I would love to understand how we can fix this. The VPN servers don't take terribly kindly to it. We've got a similar setup with DNS as well. So KeepAliveD is the bit that makes it all work. As long as you've got working IPv4 multicast, you can use that for, it will use that for VRRP, which is the configuration we use it in. I know that you can do IPVS with KeepAliveD. We don't do that because we've found bugs in it. And I know several other people have found bugs in it as well. VRRP, however, just works. With the 2 load balancers there, we can always make sure that there's an active load balancer as long as both of them don't go down. And if they did, we'd be very quickly spinning up another one or failing over to the secondary site. Getting stuff to our backend services, within that site we use HA proxy. We actually use that not in a TCP proxy mode, although you can use it in such a mode. We actually run it through as a proper HTTP proxy in our system. If we want to upgrade one of our backend servers, we can take that backend server out of the pool by stopping the web server on it. We then upgrade that server. We then put it back into the pool just by starting the web server again. And that works very reliably. On Tuesday this week, we actually took out an entire VM host for about 2 hours while we had some hardware being replaced. And as far as I'm aware, nothing batted an eyelid, which I was really quite happy with, given how hard it's been. And how much does it actually cost to run this? If you look at the actual raw cost of the data center space and all that sort of stuff, it costs less than 4 figures a month to run this. And that's across both the sites. And it's under half the cost of what our client was paying in Amazon. Now, we've had a few issues that we've been working with HP on, mainly down to RAID controller issues, which have been very, very unfortunate. But we're expecting the support costs to go down as well in terms of my time and actually keeping things running. So, in general, this has actually saved my client quite a lot of money, although at the moment the reliability of it's been a bit hit and miss, unfortunately, but it's been mainly down to hardware. Moving forward, though, we're looking at several other bits, primarily to do with high availability on the VPN servers and getting all the VPN servers to share their IPsec security associations with each other, which should allow for a more seamless failover, particularly in the case of the checkpoint firewalls that we're struggling with. Automatic failover between the sites is something that we're working through as well, and that's actually been quite difficult, mainly because we have to try and the 2 sites have not got a direct connection between the 2 of them, apart from via some kind of IPsec VPN or virtual tunnel interfaces, which is really quite difficult. And the final bit of the puzzle that we're actually trying to sort out is their databases, because clustering with 2 sites where you don't have any way of knowing which site is primary because you've managed to nicely partition it down the middle. When one of them goes offline, it becomes a bit difficult. We are looking at how we handle this with a potential third site possibly sat in the cloud somewhere, just sitting there waiting to run things. There are a couple of people who I need to say a huge thank you to, who made this project for this client possible, and it's the guys at CDW and 4D and also Bytemark, who between them have all worked on this project. But other than that, I would just like to say thank you very much, and if you've got any questions, please ask me now or drop me an email later. And I'd be very interested to hear from anybody, particularly anyone who's got any experience with dead peer detection and checkpoint.
Any questions? I have a question.
Yes.
If I'm allowed to ask one. How does this scale very quickly? Because the cloud's all about hyper. You know, when I think of cloud, I don't think of a couple of boxes in a cupboard.
No.
I think of wildly massive data centers all over the world.
Yeah. So part of this client's system, the vast majority of this client's application doesn't need to scale that quickly.
Right.
And that is part of the reason why this solution actually works for them. In addition, the servers that I've spec'd and the equipment that I've spec'd can cope with far more capacity than is actually being used at the moment. And if we suspected that a period of high demand was going to come, we could increase that, and we can also spin up virtual machines very, very quickly in about 5 minutes or so from cold if we had to, in order to cope with additional load.
Okay. Any other questions? There's one in the middle there.
It sounds like your demand is fairly predictable. I wondered why not opt for a reserved instance or spot instance model in AWS?
So in the particular case here, reserved instances and spot instances would have worked for the application layer. However, the fundamental problem or the main thing that forced the move out was the networking layer itself and the IPsec VPN requirements of the clients, and how crowded the address space was becoming, and how difficult it was to work with different IPsec solutions within the cloud platforms.
Thanks.
Any other questions? No, thank you. Thank you very much.
Thank you.